Okay. So now you are able to share, see the screen, right?
Sir.
Okay. So today we are going to discuss the core topic, which is known as hypothesis testing. Okay. Okay. So so you already have studied in master's level the hypothesis testing. Okay, you already have studied. We are basically going to revise the hypothesis testing, this topic, but there are some prerequisites of hypothesis testing. I have not previously discussed about the prerequisites, but as we move on, we will be focusing on the prerequisites also. It will be actually beneficial for us. We will be able to understand if we look for a bottom-up analysis, then, or bottom-up approach, whenever we will discuss, then we can understand that why it is required, why these things are required, and uh, uh, what are the interrelationship. Those things we can very easily understand. That's why we will start from hypothesis testing. Okay. So in hypothesis testing, as you can see in the slide, that in our daily life, significance is meant as big improvement, but the statistical significance indicates that we have evidence that the result we see in the sample also exists in the population. Statistical hypothesis testing is used to determine whether the result of a data set is statistically significant, or is the difference in the sample is the evidence of difference in the population. Okay. And you can also see the formula of significance level alpha is equal to given by 1 minus CL, that means confidence level. So basically when you conduct some management oriented research work, and when you do some survey, basically you deal with some hypothesis testing, right? And you have also seen that you propose some null hypothesis and alternative hypothesis. So you do basically hypothesis testing from a survey. Okay. Now, what is actually hypothesis testing? Hypothesis testing means you propose some hypothesis which is actually known as alternative hypothesis or research hypothesis, and you would like to test that whether you can reject your null hypothesis, or you cannot reject your null hypothesis. You test. So basically from hypothesis testing, it is basically related to inferential statistics. What is inferential statistics? Inferential statistics means you want to derive, you first do the sampling, and from your sample survey you actually want to conclude about your population. Okay, we all know that. Suppose you want to test whether the scholars of VIT, whether the research scholars of VIT, whether they are stressed or not. Okay, so that you would like to test, suppose. Okay, so this is a kind of hypothesis testing. Okay, this is a kind of hypothesis testing. So you will you typically, when you do hypothesis testing, when you do some survey, what do? You cannot when you do some survey, you cannot take the data from all the population. Okay, that is not possible. Okay, suppose you would like to test that whether environmental proactivity is positively related to financial performance or not. Okay, or whether environmental proactivity enhances the financial performance or not. Okay, or suppose you want to test whether the green marketing, okay, it enhances the financial performance or not. Okay, so now there, if you suppose, if you want to make a survey on India, there is a lot of companies are there. Okay, lot of companies are there. So you cannot take the data from each and every company. That is not possible. Okay, if you can take all the data, then it is known as the population. Okay, suppose if you can take the data of all the research scholars of VIT, okay, so that will be known as the population of VITian research scholars. Okay, but in practice you are not able to take the data of all the industries or all the scholars or all the entities. It is not possible. You only, whenever you conduct some survey, you only deal with some samples. Okay, that means you only take the data from some samples. Okay, and then you infer about your population. That means you take a decision about your population through a method or through a statistical method, which is actually known as hypothesis testing. Okay, that means hypothesis testing is actually used in survey. Okay, you take data from some samples, and through the statistical method of hypothesis testing, you draw some conclusion about your population. Okay, so that is known as the hypothesis. This kind of testing is actually known as hypothesis testing. Okay, so a statistical hypothesis is an assumption about a population parameter. Okay, this assumption may or may not be true, but the statistical hypothesis is an assumption about a population or the parameter. Okay, now we know that there are two different hypotheses. Okay, one is a null hypothesis and another is alternative hypothesis. One is null hypothesis and another is alternative hypothesis. Okay, alternative hypothesis is also termed as research hypothesis. Alternative hypothesis is also termed as research hypothesis. Okay, so suppose what could be an example of null hypothesis and alternative hypothesis? What could be the example of null hypothesis and alternative hypothesis? An example of null hypothesis, null hypothesis simply means that there is no difference. Okay, or the difference that you are observing, that is by chance. Okay, there is not some specific reason behind it, but the alternative hypothesis states you that whatever you are observing, that is not by chance. Okay, there are some there may be some specific causes behind it. Okay, suppose the I can give you some example that will be the idea will be very much clear. Suppose in your you would like to propose, you have proposed a research hypothesis that the research scholars of VIT, that they are very stressed, they are stressed. Okay, and suppose you have you are actually you have a 5-point Likert scale, and suppose you are obtaining the feedback from the VITian research scholars, and if the average feedback is greater than 4, okay, out of a in a 5-point Likert scale, that means this is your actually the feedback is actually your variable. Okay, and the stress variable feedback is actually the stress variable, and the population mean, suppose if you can take all the data from all the research scholars, and suppose if your population mean is above 4, okay, in a 5-point Likert scale, then you can conclude that the VIT research scholars, they are stressed. Okay, now it is not possible that you will take data from all the research scholars. So you are taking the sample. Okay, suppose you are taking 20 samples. Okay, and you have taken the average of it. Okay, and you are going to test that whether it is significantly your null hypothesis will be that the VITian research scholars, they are null hypothesis means simply no difference. That means your null hypothesis will be that VITian scholars are not stressed. Okay, and your research hypothesis or alternative hypothesis will be that VITian scholars, they are stressed. Okay, so this will be the example of the null hypothesis and alternative hypothesis. Suppose you are testing the relationship between environmental proactivity and financial performance. So you can make a null hypothesis like there is no relationship between environmental proactivity and financial performance. And your alternative hypothesis or research hypothesis would be there is an evidence, sorry, there is a relationship between your environmental proactivity and financial performance. Okay, or there is a relationship between green marketing and environmental performance, sorry, financial performance. So in this way you can propose your research, your hypothesis, your null hypothesis and alternative hypothesis. Okay, now how can you perform the hypothesis testing? Okay, usually the hypothesis for the purpose to test, in order to test the hypothesis, you can use Minitab software or stat graphic software, or there are several other software packages by means of which you can very easily do the hypothesis testing. And also you can get different videos on YouTube, okay, to perform the hypothesis testing, how to do the hypothesis testing. Okay, I am not showing you that how to perform the hypothesis, because uh, the way you will perform the hypothesis, it is very, there will you will get lot of videos. The software that is not fixed, you may not use Minitab, you might use some different software. So whatever software you use, you can do it, you can use that software, and based on that you search videos on YouTube, and you will come to know that which how to perform the hypothesis testing. Okay, so what result you will get? Okay, so based on the nature of hypothesis testing, okay, based on the nature of hypothesis testing, I am saying you the based on the nature of hypothesis testing, because later on we will see that there could be different types of tests. there could be Z test, there could be F test, there can be T tests. So a lot of different types of tests are there, and based on that you will get some test statistics. Okay, so based on that test statistic, you can you can you will have some chart or table. Okay, suppose you are calculating the Z statistic. Okay, so you will have a Z statistic table. Okay, so based on that table you can take your decision that whether you need to accept the whether you can reject your null hypothesis or you cannot reject your null hypothesis, that you can test. Okay, or alternatively you can also go through your p values. Okay, p value is a very very common technique. Okay, that also you can find the p values from the from table. Depending upon your statistic, you can find out the p value, and also you can take your decision. Okay, but the thing that is most commonly used, okay, since nowadays software is available, so automatically it will show you that what is your p value. Okay, any kind of hypothesis test you do, okay, whatever be it, it may be Z test, it may be F test, it may be T test. There are also 3 different types of T tests. So whatever be the test, you simply you will look at your p value, what is your p value. Okay, and usually if your p value is less than 0.05, that means you can reject your null hypothesis, and you can say that there is enough evidence to accept your there is enough evidence to accept or to believe your research hypothesis, or your research hypothesis, or your research hypothesis, there is sufficient evidence. Okay, you can say. Or and alternatively, suppose if you see that your p value is greater than 0.05, okay, so then you will say that you cannot reject your null hypothesis. That means there is not sufficient evidence. Okay, there is not sufficient evidence that you can reject your null hypothesis. Okay, so that's why it is there is a very easy way to remind it. It is like if p is, we say, if p is low, null must go. If p is high, null must fly. Okay, if p is low, null must go. If p is high, null must fly. You should remember this. That's it. What is go means? Go means live. Simply live.
Simply leave.
Okay, go means simply live. That means if your p value is low, that means your null hypothesis will be, you can reject your null hypothesis, and there will be enough evidence of your research claim or of your research hypothesis. You can say if your p value is less than 0.05, then you can say that there is enough evidence that the VITian research scholars are stressed. But if your p value is high, then null must fly. Null must fly means null will remain. That means you cannot say that there is enough evidence,
Enough evidence.
there is not
There
enough
is
evidence that uh, you can say that the VITian research scholars are
that the right search.
stressed. Okay, so this is so this is what the you know this is this is the procedure you should mind. This is actually very in a nutshell. You can say that if p is low, null must go; if p is high, null must fly. Okay, you can also take your decisions actually. Now suppose if now you can ask me that there are two questions there will be, that what is actually p value. Okay, this is one question, and another question will be that why we take the cutoff of 0.05 to consider the p value. Okay, basically 0, though I am talking about 0.05, but 0.05 is actually nothing but it is alpha. Okay, 0.05 is nothing but actually alpha. Okay, so you can see I will discuss that later, but first let me talk about what is p value. Okay, so as you can see in the slide, that p value or the observed significance level is the probability of obtaining the observed results of a test statistic at least as extreme as the results actually observed during the test, assuming that the null hypothesis is correct. Okay, so you can understand that you just have a look at this figure. Okay, so this shaded portion, this is actually reflecting your p value. P value is nothing but probability value. Okay, it is at least as extreme as the results actually observed during the test, assuming your null hypothesis is correct. Okay, so basically p value, if you consider your null hypothesis as correct, okay, so during that time you can find out your actually p value. You can calculate your p value depending upon your distribution or the test statistic that you are considering. Okay, so you can calculate the p value from that. Okay, and p value is actually, it depends upon your test statistic. Okay, there is a relationship between test statistic and p value. Okay, there is a relationship between the test statistic and the p value, because for a particular test statistic you will get a particular p value. Okay, so suppose uh, here you can see that I can show you one example. Suppose your null hypothesis is mu is equal to 30 hours. That means your mean is 30 hours. And your research hypothesis and alternative hypothesis is showing you that mu is less than 30 hours. Okay, mu is less than 30 hours. This is your research hypothesis. Okay, now you are considering the level of significance as alpha is equal to 0.05. Okay, I have already told you that usually if we consider the p value with respect to the value of 0.05, what is 0.05? 0.05 is nothing but the value of alpha or the significance level. Okay, and significance level is nothing but it is given by 1 minus confidence level. Since usually, suppose you can see here that earlier I have shown you this formula, that significance level alpha is given by 1 minus CLR confidence level. So usually we prefer the confidence level is 95%. Okay, that's why we consider the significance level is equal to 0.05. But in some cases, okay, in some cases you will see that very high significance level is required. If you require very high significance level, then also some even less than 0.05 significance level, it may be 0.03 or 0.02. Okay, that means a very high confidence level. In case you desire very high confidence level, then significance level will be dropping actually. Okay, so it depends that what kind of confidence level you are trying to achieve. Okay, so based on that, you will prefer your significance level or the cutoff value. Significance level is actually nothing but your cutoff value. Significance level or alpha is nothing but your cutoff value, by seeing which you decide, you actually compare it with your p value. Okay, so suppose here in this case, you are dealing with z statistic. Okay, so this is the formula of the z statistic, and you can see that your test statistic is minus 1.46. Okay, this is your, suppose uh, uh, this is your, suppose uh, uh, 0, suppose your z value is, your test statistic is minus 1.46. Okay, suppose you have performed your, actually this part is actually, it can be very easily computed by your software, that your test statistic value is minus 1.46. Okay, so you can perform your research hypothesis based on your test statistic, or you can perform your research hypothesis also based on your p value. In both the cases, you will get the same results, because p value is nothing but it depends upon the statistic itself. Okay, for example, you have got your test statistic here, the z statistic, you have found that minus 1.46, and since your level of significance alpha is equal to 0.05, you can very easily understand that what is your confidence level. Your confidence level is 95%, you can understand. Okay, so for 95% confidence level, okay, your the z value will be 1.96. Okay, your z value will be plus minus 1.96. I can show you. Yes, this is, if your confidence level or confidence interval, it is 95%. Okay, so your z value is minus, if your confidence level is 95%, your z value is 1.96. Okay, plus minus 1.96 in fact. Okay, so if you see your this graph, okay, you can easily understand that your test statistic minus will be somewhere here, will be your z statistic will be minus 1.46. Okay, here it will be like here minus 1.46, and your cutoff value z will be value at 95% confidence level, it will be 1.96, minus 1.96, somewhere here. Okay, and so what will be your conclusion? Your conclusion, so this actually your test statistic, it lies in this region, fail to reject null hypothesis. Okay, so your ultimate conclusion will be there is not sufficient evidence of your research hypothesis or alternative hypothesis, and you do not reject the null hypothesis. This will be your conclusion. Okay, so this is the test statistic. Now if you want to find out, suppose the p value, you will see that in your software, you will see your test statistic will be minus 1.46, and your p value will be given as 0.0721, which is actually greater than 0.05. Your, suppose if you consider this graph, okay, you will see that it is 0.0721. This is the area is 0.0721, and your 0 point, this is greater than 0.05. The area of 0.05 will be lie somewhere here. Okay, this will be the 0.05 in this area. So again, in this case, it is also come to the region of this area is actually coming or falling in the region of fail to reject null hypothesis, this in this region. Okay, so again in this case also you are you cannot reject your null hypothesis. Okay, now if you ask me that how this actually this value of test how this value of test statistic and p value actually comes, then I can also show you that this p value actually it is here in this case we can derive it from the z table. Okay, from the z table we can see it, because here we are dealing with test z test statistic. I can show you. uh, yes, this is the table you can see. Okay, this is the z value table. You can see that from minus infinitive to this region, what will be the area that you can calculate from minus infinity to this area, from any area from this region. So you can calculate it. You can calculate it very easily. Okay, so this is just based on integration, because you know already that suppose this is nothing but a function. Okay, this is nothing but a function. So the function has got some formula, and you are actually integrating that particular formula to find the area for a specific range. Okay, this is the idea. Suppose I would just like to show you the curve of the normal distribution. Okay, uh, yes, this is you can see that this is the curve of the normal distribution. What is normal distribution? Normal distribution is a continuous probability distribution wherein most of the values of data set lie in the middle of the range or around the mean. Okay, and then rest of the data taper off symmetrically towards either extreme. So if you are asked that what is the probability density of the normal distribution, this is the probability density of the normal distribution. Okay, that means this is nothing but a function. You know that you have studied earlier that y is a function of x. That means the for a particular in a function is nothing but different values of x's or independent variable. You will get different values of different dependent variable. Y is your dependent variable and x is your independent variable. For different values of x, you are getting different values of y or dependent variable. So that is actually